Today we're looking at the exponential function, and in particular graphing the exponential function. So we're asked to graph the following function. Y equals 1/2 raised to the power 2x minus 6 minus 3. So the first thing we're going to do is try and determine the parent function and then what transformations have been performed to the parent function. So our parent function, what's right here, is y equals 1/2 raised to the power x. Now, what transformations have been performed on the parent function? Well, let's have a look. So we'll just, again, we have our 1/2 raised to the power. Let's see. Let's factor things out like this. Okay, so we have the 1/2 now. We've raised it to the power 2 times x minus 3. So this 2 here is a horizontal compression. Let's write that down. Horizontal compression by a factor of 2. This 3 here is a horizontal translation. Right. 3 units. And this 3 right here is a vertical. No, that doesn't look so good. Let's write that so it's a bit more legible. A vertical. Is that any more legible? Vertical translation down 3 units. Okay, so those are our transformations. So now we need to actually graph this. So sometimes the easiest way to graph transformations on a parent function is to start with the parent function. So why don't we do that? Well, before we do that, why don't we consider our x-intercepts and our y-intercepts? Okay, so our x-intercept occurs, let's start with the y-intercept. The x-intercept's a little tough. So y-intercept occurs when x equals 0. So if we let x equal 0, y equals 1/2 raised to the power negative over 6 minus 3. 1/2 raised to the power negative 6 is actually 2 raised to the power 6. 2 raised to the power 6 is, I believe, 64. 64 minus 3 is 61. Okay. So that's our y-intercept. Our x-intercept is a bit of a mess. Okay, x-intercept. So we're going to let y equal 0 to get our x-intercept. And then we need to solve for x. So I'm bringing the 3 over to the left-hand side. Okay, so now what do? We need to take logarithms, actually. Or before doing that, we can rewrite the right-hand side so we don't have a fraction as a base. So if we do that, we have 2 raised to the power negative 1, all raised to the power 2x minus 6. So we get 2 raised to the power 6 minus 2x. Okay, so now we can take the logarithm of both sides. Using the property of logarithms, on the right-hand side, we have 6 minus 2x times log 2. And now we just solve for x. Okay, remember log 3 and log 2 are just numbers, so we treat them as such. Okay. Log 3 over log 2 minus 6, all divided by negative 2, and that's our x value. That's a bit of a mess, but I can punch that into our calculator, and that's indeed a positive number. Yes, that is a positive number. Okay, so we have these values, and so that's great, but we need to actually graph our function. So let's go back up, and let's do it to the right so we can see our parent function and our transformed function. Okay, so let's put some axes in. Let's see. Okay. Actually, let's do this. All right, so our parent function looks something like this. Right? Y equals 1/2 raised to the power x. So it's a decreasing function. It has a horizontal asymptote, which is y equals 0 or the x-axis. The y-intercept is 1. Anything raised to the power 0 is 1. Okay. So now let's consider our transformed function and all the transformations. So the first one that might be nice to look at is a vertical translation down 3 units. So that vertical translation moves everything down, including our horizontal asymptote. So our horizontal asymptote is now, let's use a red line here, is now here. So this is y equals -3. Okay, that's a horizontal asymptote. We also have this horizontal translation 3 units. So if we consider the, let's see, let's pick another color, it's black. The y-axis, our y-axis has now in some ways moved over to the right 3 units. So let's draw our new y-axis. Okay, let's just turn it into a dotted line. I don't get confused. That's where our new y-axis is. Okay. So this means our point 1 here, our y-intercept has moved down 3 units and has moved to the right 3 units. So it's going to lie on this line right here, which is a line x equals 3. So this point, our original y-intercept has now moved to the point 3, -2. That's good to know. We found our y-intercept for our new function to be 61, so way up high. So let's say it's here. It's probably further up. And we found our x-intercept for our new function to be around here. So our new x-intercept was this strange value right here, -1/2 of log 3 over log 2 minus 6. That's our x-intercept. Okay. That is actually a value, I think, between 2 and 3. So somewhere here. Okay, so now let's see if we can join these dots as smoothly as possible. It might not be easy. We have something. Well, let's see if we can fix that. So that's our new function, something like that. Not not wonderful, but so we've translated our parent function down 3 units to the right 3 units, and we performed a horizontal compression, and it does look a little bit compressed horizontally. So this is our new function y equals a half raised to the power 2x minus 6 all of that minus 3. Whoops. Good. So that's a graph of an exponential function with transformations applied to it. This brings us to the end of our session. If you have any questions, you can email us at info@raisedbymarks.com or call us day or evening. And feel free to ask us any questions. We'll be happy to help you. And thank you for watching. We look forward to seeing you again.